Okay, so here's your review for tomorrow's test. This is the third test in Unit 1, so we're calling it Unit 1C test. Everything on number 1 is about determining whether the triangles are similar, and if so, figuring out how you know. Well, there are 3 triangle similarity postulates. And they're kind of like those triangle congruence postulates, but not exactly the same. There are 3 of them, and they are angle-angle, where you know at least 2 pairs of corresponding angles are the same. And the third one would automatically have to be the same because, remember, they all add up to 180. Side-angle-side, and side-side-side. Side-side-side is probably the one we've used the most. But for all of these in part 1, on number 1 really, you're going to have to decide whether you could use one of these to show that they're similar. If you can't use one of these to show that they're similar, then the answer is they're not similar. All right, so first of all, let me just go back and point something out about these. Angle-angle, the angles have to be exactly the same, because in similar triangles, the angles are not similar, not proportional, they're exactly the same, they're congruent. On side-angle-side, however, we're dealing with a combination of sides and angles. And a piece of hair, excuse me. And like for instance, if I knew a pair of sides, a pair of angles was congruent, and let's say that this side and this side are proportional. So remember, for sides it's about proportional, not about congruent. And this side and this side are proportional. So this would be side-angle-side, because I have 8/12, which reduces to 2/3, or 0.6 repeating. And I have 10/15, which also reduces to 2/3, or it's 0.6 repeating as a decimal. And those are equal. So I have 2 pairs of proportional sides, that's the 2 S's, and then it's the angle between where the 2 sides meet that I know is congruent on both triangles. So that's side-angle-side, and side-side-side again, it's just the difference here compared to congruence is that the sides are proportional, not the same. So like if this was, I don't know, 6 and 8, this could be 7.5 and 10. This could be 12 and 16. And if you check all of those, 6/8 is 3/4, or 0.75. 7.5/10 is 3/4, or 0.75. And 12/16 is also 3/4, or 0.75. So we know that those are proportional and the triangles would be similar. So that's what you're doing in 1A through F. Okay? Now on A, you're comparing 16, and let me just remind you that anytime you have overlapping triangles, it's not a bad idea to go ahead and draw the triangles separately, like draw KBC with its sides of 16 and 25, and then draw KLM, the big triangle. Okay, here's why. For one thing, it helps you recognize that K is a congruent angle pair, because angle K is congruent to itself. It's in both triangles. The other thing it helps you do, though, is to think about total length versus pieces. So like this right here, 88, is talking about all of KL. But down here, the 25 is just K to C, and the 107 is just from C to M. So to get this whole thing from K to M, we would have to add 25 plus 107, and 25 plus 107 is 132. So when I'm checking for number 1, I know that I have a pair of angles, and I'm thinking about side-angle-side maybe. But I have to check and see if 16 divided by 88 is the same as 25 divided by 132. And you do that in your calculator. 16 divided by 88, that gives you a decimal. 25 divided by 132 gives you another decimal. compare them, and they will not be the same. So I would probably say no, because KB over KL is not the same as KC over KM. Those side lengths are not proportional. There's my answer. Part B is also going to be no. We can't say that they're similar because there are no sides at all. So remember, we're using, on all of these, we're using side, angle, side, 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 or angle, angle. If there are no side lengths at all, then I'm definitely not using either of these. So all I could use is angle. Angles, well, at two pairs of corresponding congruent angles. And I'm going to use a different kind of marking just to show. Okay, those are congruent because they're vertical angles. But that's all. That's all I've got. So that's a no because it's not enough info. I don't have two pairs of angles. So I don't have angle, angle. And then this one looks like it is tailor-made, or part C. Looks like it's tailor-made for side, angle, side. Side, angle, side, side, angle, side, because remember, vertical angles are congruent. The problem is it doesn't match up though. If I do 16 over 39, that does not equal 16 over 40. You can kind of see that one at a glance because these two are the same here. They're not the same here, so there's no way 16 over one number is going to be the same as 16 over a totally different number. So, excuse me, again, no, because du over SU is not equal to EU over TU. Now notice that when you have a situation like this one, where they're kind of like a bow tie, or this one, or even like this one, you can't assume the ones on the same side align. You have to check, you have to make sure you compare smallest side to smallest side and largest side to largest side. This one, it doesn't matter which way you compare them, it doesn't work. But like down here, it can crisscross. It could be that 8 goes with 49 and 14 goes with 28. Now that's not the case here because 8 is the smallest and 28 is the smallest over here. But sometimes it crisscrosses. This side over here matches up with that side and this side over here matches up with that side. So make sure you're looking at actual side lengths to compare. Let's go ahead and jump to E, because this also looks like it might be side, angle, side. So let's see if we finally have one. So you've got 8 is the smallest side over 28 is the smallest side. And the question is whether that is the same as 14 over 49. And fortunately, yes, you get the same thing both times. I think it's, let's see, 2/7 as a fraction. And whatever 2 over 7 is as a decimal, that's what you get for both of these. Okay, so yes, these triangles are similar by side, angle, side. And I have to go ahead and put my letters in order. V, U, T over here goes with V, L, M. All right, on part D, sorry, I almost went to F. D, remember that parallel sides tell me things about angles. So when you see those arrows, that's telling me something about the angles. Specifically here, it's almost like a Z shape. Okay, so this is telling me that I have congruent angles. So these are alternate interior angles because the sides are parallel. So this angle up here and this angle down here, alternate interior angles, that's one angle pair. Then I also have this other angle pair. So that's two angle pairs. Two angle pairs is angle, angle. So yes, these triangles are similar. Now I just have to think about how they match up. EFG is this bigger triangle that's on the bottom. So on the bigger triangle on the bottom, E has one little blue arc. So I come up here and I look for the angle that has one little blue arc, and that's my F. Okay, and back to the big triangle, EFG, EF. F has no markings. In this triangle up here, H has no markings. And finally, G in the big triangle on the bottom has this marking, and E has that in the other one. And that is by angle, angle. So I would say by angle, angle. Okay, on F, I don't particularly like F because I feel like it's, with the decimals, it ends up being hard to compare. And it looks like they're almost similar, but not quite. And I'm not sure if the intention is that they are, but it doesn't actually end up working. So let's just talk about how the shape could work. Actually, let me go ahead and give you another example. It looks just like this. Let's say I've got a big right triangle, which is what you've got. This is a number, what is it, D, E, E, F. Do I hear a G? Not really. Okay. Actually, the right angle symbol is over here in yours, but it doesn't matter where it is. If it's a right angle on one side, it's also a right angle on the other because this is a straight line, or at least mine looks a little crooked, but it's supposed to be straight, which means it's 180. So 90 subtracted from 180 leaves you with 90 for the other angle. All right, so let's say I'm going to use the same letters that are on that problem. Okay, let's say we have this. Nope, that's not what I meant to do. All right, let's say we have some nice whole numbers. Basically, we have 3 triangles here. Okay, so there's a lot of different things you can compare. This triangle it's like it's flipped up on its back. Right here. I think I did it wrong. I did. I'm sorry. That's the 9. Okay, and so this is sort of like I took this triangle, it looked like this, and then I tipped it up on its back and moved it up here. Okay, so they're positioned differently. So you've got 3 different triangles, all of which are similar. You could use the Pythagorean theorem to find your missing side length here. In other words, 9 squared plus blank squared, or we don't know what squared, equals 15 squared. So this is 81 plus x squared equals 225. Subtract 81 from both sides. I get x squared equals 144. And then take the square root of both sides, and I get x is 12. So this is 12. So we can find the missing side length by Pythagorean theorem. I used the triangle on the left to do it, but you could use the triangle on the right to do it also. So now we have, this is the smallest triangle, MDC. Here's the smallest side, here's the middle side, here's the big side. I'm going to put them all positioned the same way. Okay, I'm going to put the smallest side on the left, the middle on the bottom, and the hypotenuse sort of up or on the right. Then MKC is already in that position. Smallest on the left, middle on the bottom, and here's that one. Now there's also the whole big triangle, okay, which is 15 for one side, 20 for another side, and 9 plus 16, this whole side from D all the way over to K. 9 plus 16 is 25. So if I put this one, the whole big triangle, so the smallest one's on the left, that would be MD. And the medium-sized side, so MD is 15. 20 is the other leg. That's the middle side length. And the whole hypotenuse is 25. So these are my 3 similar triangles. Okay, and they are similar. You can check them. 9 over 12 is 3 over 4. 12 over 16 is also 3 over 4. 15 over 20 is also 3 over 4, or 0.75 for all 3 of those. Okay, so these are proportional, and then you can check these are proportional, they're all proportional. So DCM, here's D, CM